Hello and welcome. I'm your host, Dr. Ruby Gill, and I honor to welcome you all on the behalf of lovely professional university. So, attendees, I know you might be wondering the reason of gathering virtually. So, let me tell you and reveal you the reason for this. For today's webinar, we are going to have an incredible session with our experts today, as he is going to tell us all about to program a basic robot Firebird 5th. So I'm sure you are as excited as I am. So allow me to introduce our expert of the day, Dr. Manmohan Sharma, Professor, School of Computer Applications, lovely professional university. A dynamic professional with an experience of more than 7 years as an academician. His expertise strongly lies in wireless networks, cloud computing, robotics, and robotics program automation. Over to you, sir.
Yeah. So we are going to start this particular program, this particular workshop on how to program a basic robot. And this particular robot, Firebird 5, we are going to use in this session. And when we look at this robot, you can see the robot is like kind of robot that contains some chips on it, and then there are some there is a battery, and there are some sensors attached with it. Okay, so here you can see a lot of sensors, lot of batteries, lot of engine, a lot of motors available here, and then a very big chip over there. Okay, PCB over there. So this particular robot is one of the robot developed by the IIT Bombay by Next Robotics, including the so Computer Science Department of Computer Science Engineering, IIT Bombay, in collaboration with the Next Robotics, developed this robot Firebird 5. So this is one of the fifth robot in this series of Next Robotics. So here, a lot of different things, as we know that robot is working on the on a particular adapter board, and here we are using mainly 3 adapter boards here. There is your Atmega 2560, P89V51RD2, and LPC 2148. Here in this particular robot, which you are seeing here, okay, in this particular robot we are going to use this Atmega 2560 AVR. Okay, and obviously we can program this robot and make this robot to work according to our requirements. Here, this particular robot also contains some slots where we can add our own custom designed controllers, microcontrollers with this. So let's start with this building blocks. So building blocks of a robot, if I discuss this, building blocks of a robot are based on around 6 components, mainly 6 components. These components are sensors. So here you can see the sensors in the front of this. You can see the sensors. I think it is visible. These 2 are the sensors. So these sensors are used for sensing the environment. Not only these, here we can say at the end you can see there are some LEDs type of things are connected with this robot. These are also sensors. Okay. Second thing are actuators. What are these actuators? These actuators are actually responsible for the movement of robot and its part. So the movement we are using these wheels, the motors, okay, and there are some other actuators we can use in that. These are the like the arms for the robot, okay, and then in this robot we are using the controllers. So these controller processor we can say that these are the brain of the robot, where we can feed the program, and then this particular robot will start working as per our requirements. Okay. Third thing is the intelligence. Third component or third block is the intelligence. Intelligence means these are the programs that we can write and then execute within the robot, install within the robot, and then execute it to perform a desired set of action. Okay. And next thing is required power. Power is actually the batteries. This particular robot is taking the power from the batteries. So here you can see one battery is connected over here. There is the battery which we can use. Okay, and this battery is actually required for the. It will provide the power to the robot. Okay, here you can see this. Okay, so these batteries are actually used for powering the robot and provide the power to the robots. Now connect, I just connected it. And here, this particular battery just used to provide the power to different components like actuators or the processor or the mother or the sensors. Okay, and then at the end, now we require one more thing: the communication. How how the robots can talk to another robot or the PC. So we are using here this particular cable so that we can pass the program from from the computer to the robot. Okay, what we do? We just pass the program from computer to the robot. For that, we are using a program for embedded C, and this program is actually known as this program is actually we call it Atwell Studio. Okay, now come to the next. So here you can see this Firebird 5th Atmega 2560 platform. So this platform is attached with a AVR architecture based adapter board. Here this adapter board contains a microcontroller manufactured by uh, this Next Robotics, and the name the number of that particular is Atmega 2560, and this one used as the master controller for the robot. So whatever program we feed, it will be feeding into that particular master controller. And then we look at the various sensors. Those are available on this uh, Firebird platform. So first sensor is a sharp IR range sensor. Sharp IR range sensor. And in this robot, you can see it here. At the front, there is your sharp IR range sensor. Okay, this particular sensor is used to sense the distance from a particular object. Okay, so what you do is just use this IR LED which is in the front of this. Okay, here in the presentation you can see it here. Okay, and then here you can see this is your CCD array that will just catch the signals and then use this signal for detecting the range. So here we are using the infrared sensor on the Firebird, and this is the working of your Firebird sensor. So here you can see the robot can sense whether it's a good range or the bad range. That means your sensor just sense it when your object is in the good range or is in the bad range. So what is the good range? Good range, when your sensor sense the object completely like this. Like if an object is placed here, You can see a big dotted line on the top. Okay. So this that means the object is far from the sensor. Okay. So this IR LED just send this signal, infrared signal, towards the object, and your your sensor. Okay, then object will scatter this reflection, scatter these IR lights to the IR detector. That is your CCD array. Okay, and once this IR detector sense this position. Okay, here you can see that when the object is far, this particular light, this particular reflection is in somewhere middle in the CCD array. Okay, and when the object is near, your sensor sense it, or reflection is far from, or we can say the at the end of the extreme position of the CCD array. So using that particular calculation, we can find out that, or your robot will recognize that where the object right now, whether it is far or whether it is near. So here one video is available here. On the basis of that, we can say that. So here in this video, you can see we have placed different objects at different positions. Okay. So these positions are increasing, and so these are 10, 40, and 70. So this is your robot when we programmed it for just sensing it. So you can see, if you are able to see this one, this says that obstacle is here. When we remove it, where it is far, so it say that obstacle is far. And at the third position, when the middle object has been removed, it says that obstacle is very far. I think you can see that. Okay, obstacle is very far. So this is how we can sense how this robot can sense the distance. Okay. Now the next is the IR proximity sensor. IR proximity sensor. So this proximity sensor is actually used for identifying a particular object in that particular area. So the first sensor is used to identify the distance, whether it is far or the near. It just used to identify that whether an object is here or not in that proximity, in that particular region. So for that we are using, here you can see, these are the sensors. This is the sensor available connected here. Is it visible? Okay. So this sensor is actually IR proximity sensor, which we call photo, which using a photo transistor here. Okay. So IR proximity is used on this, and we can sense that whether any object within that particular proximity is available or not. Okay. Clear? So now next is the white line sensor. White line sensor is mostly used for sensing whether when it is moving ahead or forward or backward. Okay, so it sends the white line and it follow it. So here you can see below that, you can see these are the white line sensors. Okay, which you also see in that PPT also in the presentation. So again, this is also using the RI LED or infrared LED, or which is a transmitter, and a photo transistor is used to receive the signal. Okay. So what you do is just check this. So what is the color of that particular line? So here you can see there is your high power. When high power red light is incident on this white line. Okay, so what do you do? It just emit the light on all the surface. Okay, and then when the light is reflected back to the phototransistor, okay, it just check that what is the color of that particular surface. Okay, and then using that particular calculation, it follow that path. Okay, so these three sensors are actually used. So one is for the middle, this is then this is for the left side, this is for the right side. Okay, so when these are using, when these, and behind that you can see these are the transistors. Photo transistors. Okay, these photo transistors are used to receive the light, receive the color, which color is currently visible or to these sensors. So every particular sensor used to identify the color on which it is currently positioned. Okay, and then send back the signal to the photo transistor. Now here we are just showing you one line following robot, the program which we have created to follow the line. You can see in that there is a line of white line is there, and robot is following that particular line towards the object. This also show you the proximity sensor, working of the proximity sensor. So it follow the line as well as it also see whether any object is within that proximity or not. So here you can see that its obstacle is very near to this robot. Now next one is the position encoder, and this position encoder is mainly used to identify the position of this particular wheel. Okay, how much distance is moved by this wheel. Okay, so this position encoder is available somewhere here in between. You can see the position of this sensor available on look at the figure in the presentation. Okay, so this position encoder is available somewhere here in that. Okay, and these grooves are actually used to identify that how much distance has been covered. So position encoder just calculate that how many grooves are moved and then how much distance will be covered. So when one groove is passed on from the position encoder, that will that assume that how much distance has been covered, and then how many grooves are moved. Okay, then it will identify that how much distance will be covered. So there is a proper calculation for that, and we can show you that I can show you that that how the speed will be calculated using this position encoder. So there is one experiment we did that calculates the speed of the wheels. Okay, at uh, different periods. Okay, so here you can see here we increase the speed by pressing this. Current speed is 0.0000. That means your wheel is now not moving. Now we just make it increase the speed to 63. Now, now in that particular case, your wheel start moving. So you can see the grooves. So we can calculate the speed or the distance covered by the wheels according to this. Now increase the speed, double the speed, it becomes 126, and now speed of the wheels are now faster. And again increase the speed by 189, and now speed is faster. So there is the fastest speed, 252. Now we are going to reduce the speed gradually, 189 and 63, then sorry 126 and 63 and then 0. So right. So here now come to the other sensors. The other sensors, those are available on this Firebird 5. These are the infrared TSOP receiver. Servo mounted sensor ports are there, accelerometers are there, gyroscope here you can use, ultrasonic sensors you can use, motion sensors you can use, GPS we can add up on this device, on this robot. And here you can see that all these sensors are used for different purposes, and we can use as many as sensors on this with this robot. To power the robot, one power adapter is available here. This particular robot is required 9.6 volt power. Okay. Here we are using a battery of 2100 mAh, and uh, and we can also connect this robot to auxiliary power of 12 volt and 1 ampere adapter. So these are the two different power adapters, and here you can see a switch that will in, that will start this robot. So powering robot is very easy in that. Now let's move to this the block diagram of Atmega 2560 base robot. So here you can see in between the center of this robot, or we can say brain of this robot is your Atmega 2560 microcontroller. And with this, there is another brain we can also use, that is your Atmega 8 microcontroller. There is a small part of this, or we can say subset of the Atmega 2560 microcontroller. And then we can use different types of sensors over there. The analog eye proximity, on this particular robot, we have 5 sensors are available here. Sharp IR sensors are available here. Range sensors are available there. White line sensors are available here. The position encoders are available here. Okay. Then we can connect it to wireless modules, Wi-Fi modules. So we are using Zigbee 2.4 gigahertz wireless module in this, and we can connect it to RS-232 serial communication so that we can pass on the programs in it, and then we can also use the USB communication. So there are a lot of different components are available in this one. Dual motor drivers are available here that will be used to control these servo motors. So for that, buzzer is available in that, LED is there. So a lot of different components are available on this sensor, this particular Atmega. So now let's see that how this robot communicates. Obviously, we cannot communicate it like that, just saying some words here. Okay, we need to pass some bits and we need to program the chip of this computer, this particular robot. Okay, and this particular robot chip or Atmega 2560 microcontroller, when we program it, okay, and when we pass on the program, then these chips are activated and your program, it will work like this, that particular program. So here we are using different ports. These are the junctions where we can connect the peripherals devices to this. So here the peripheral devices are, if you all of you know that peripheral devices are the input devices or the output devices. So like in computer, we have keyboard, mouse are the input devices, and when we look at the output devices, we have our monitor, then printers, and your speakers. All these are the output devices. But in this robot, the input devices are the from where we access the data. We gather the data. Okay. So the switch, sensor, button available on this particular robot. All these are the input devices. Okay. And the output devices are the buzzer that will generate a beep sound, then LED on which we can see the different display, then motors that will take the input from the keyboard or from the program, and then activate the motors. So these are the different output devices. So in port in Atmega 2560, we are using a 100-pin controller. Here as a okay 100-pin controller. So out of these 100, 86 pins are used for input and output. Okay, so these pins are actually, when we group them together, they are known as a port. Okay, so here we can see that Atmega together 10 8-bit ports are there. They are known as port X. Port X. So this X is actually, we can say it's a variable where X is equal to A to F and HJKL. So it's look like a port A, port B, port C, port D, port F, or port H, J, K, L like this. Okay. Similarly, there is one 6-bit port. This port is port G. Okay. So 8-bit ports are available, 10 8-bit ports are available, and one 6-bit port is available. So here this the port values or port alphabets are available, and we can recognize a particular port using that particular alphabet. So we can configure each and every port bit or pin individually as input or output. Okay. So how to configure this? First of all, we just look at that. What are the other things are available in there? So here in the Atmega 2560, every port is connected with 3 registers. So these 3 registers are actually DDR. DDR X is again the same, A to H, J, K, L. Okay, A, B, C, D, E, F, G, H, and J, K, L. Okay, so we can identify a particular port and registers according to that. So DDR is there, port is there, and pin is there. So these 3 registers are used for identifying a particular pin. So how to define a particular pin? Now come to that. So first register is DDR register or data direction register. Okay. So to define a port pin as input or output. So if we define a port pin as 0, okay, that one is input. Okay. If we define a port pin as 1, that will give us that recognized as the output. So, wait a minute. Connect this. And then we will start. So 1 is at output and 0 is at input. Okay. So I just correct this one. Where's your output? Okay. So now if we define port B, so port B is there. So we define it by the 8 bits, or we can say 2 nibbles. One nibble is equal to 4 bit. So first 4 bit is first nibble, upper nibble, last 4 bit are lower nibble. So here upper nibble is defined as the output bit and lower nibble as defined as the input. Okay. So lower nibble is defined as the input. So what for input what we do? We make all the bits as 0. For output we make all the bits as 1. Sorry, I just made the mistake. It is not the correct one. 0 as yeah, 0 as input and upper nibble as output. So what we do, all the lower nibble are 0 and all the upper nibbles are 1. So when we read the position of the bit 0, 1, 2, 3, 4, 5, 6, 7, so we can write it like this. When we convert it to hexadecimal, this complete 1, 1, 1, 1 is equal to hexadecimal F. Okay, and similarly 0, 0, 0, 0 is equivalent to hexadecimal 0. So we can write the value of this DDRB as 0x F0. F is for all ones, 4 ones, and 0 is for 4 zeros. Okay, so 0x means this is a hexadecimal digit. Okay, now come to the next. So we can read the data using the PIN-X. That means we are just looking at that. A port C is defined as this one. So pin C is also defined as 0x F0. 0x F0. F means the first upper nibbles are defined as the output and lower nibbles are defined as the. Now, when port X is defined as output, okay, that means what is the purpose of this? That means we send the data present on port X pins. So like if DDR A is given as 1, 1, 1, 1, 1, 1, 1, all ones. Okay. So what we are doing, we are just defined it as the output, and here your DDR A is represented by 0xFF and port A is defined by 0xFF. That means here we define it as output and we can send this data present on this particular on these port X pins. So the so case 2 is when port X is defined as input. So here, what is the purpose of this? We can activate or deactivate a pull-up register. Activate or deactivate a pull-up register. Okay. So here the data in this DDR-A, is given by 0, 0, 0, all are 0. So what is the purpose of this? When all the pins are 1, and this is the value FF, okay, it means that all the pins of port of a particular port are activated. Okay, so we activate the pull-up. We can read the pins from that particular port, and when all the port pins are 0, that means this pull-up is deactivated. We cannot read the data from that port. Okay, read the pins of that particular port. So FF means the pull-up is activated and we can read the data from that particular port. So this is how we can stop or activate or deactivate the reading or writing in the from the ports. Now the next thing is that port D, we make the port D as output port, okay, and send this value D5. So output port is which one? D5. D means what is the value of D? D is your 13 is used as the D in hexadecimal, and 5 is the hexadecimal value 5. Okay, for 13 the value is this one 1101, and for 5 the value is 0101. Okay, so first of all, when we make this port D as the output port, so first we make this DDR, that means data direction register bit all as 1. So the value in this DDR-D will be 0xFF. And then we put the data on port D. So port D is there where the data is available 1101 and 0101. This is D5. Okay. So that means we can, when the data is read from that particular port, it will be read as 1101 and 0101 like this. Now, if we make the port A as input port and pull up is activated for all the pins, so pull up is activated means when we are making this port A as the input port, so we just pass this value 0000, okay, and make the pull up activated, okay. So all the bits should be 1 here. Got it? All the bits should be 1. So pull up has been activated. Now again the next example just tell you that we make the upper nibble of the port B as output and lower nibble of the port D as input. So and then what we do, we then pass the output binary 3 on the upper nibble and read back the data using pin D. So what we do, we just make this one, activate the pull-ups on all the bits, and then put the data on the port D. What is the data? We will put the data that all the first bits are uh, output at this. So 1101 and 0101. This is we are using. Okay, pin 3 we are taking here as 0x D5. So how the data on a uh, particular port we can activate or deactivate. Now the next thing is the direction. When you make the program, you need to know that how your uh, robot should move in the left direction or the right direction, or how it will move into the forward or move to the forward direction. So here you can see when we look at the forward direction, there are 4 bits we are using: PA0, PA1, PA2, and PA3. PA0 is used for left backward. PA1 is used for left forward. PA2 is used for right forward. And PA3 is used for right backward. So when your wheels are moving, so they can be moved forward or they can be moved backward. And both the wheels are working uh, individually. They are working in isolation. They have their own individual work available. So when the value of this one is 0, PA0 is 0, and these two are 1, that means left is moving forward, right is also moving forward, and backward values are 0. Okay, that means your as per your velocity requirement, your robot will move in forward direction. In reverse direction, we activate the backward pins, and then these two pins are deactivated. Okay. Similarly, when right movement is required, so what we do? We just make the left wheel forward and right wheel backward. So when this action happens, in that case, your robot will move to the right. So left wheel forward, so 0 1 for left wheel and 0 1 for right. So right wheel moves backward and your right wheel moves backward and stop the forward. Okay. So and for left, the same position is there, that your left will move backward and your right will move forward. So in that case, your robot turns left. Okay. Then there another position is soft right or soft left. So in soft right, your left will move forward, but right will stop. There is no movement in that. Okay. Soft left is your left is stop and your right will move forward. So it will move like this from a center. Okay. So this will happen already when we are using all these directions. Okay. So yeah. So these are the directions which we are using in that: forward, back, right, left, soft right, soft left, soft right, soft left. These are the different movements we can use in our. And now there are different avatars of the Firebird 5 robot which we are using. So here you can see um, the Firebird 5, simple Firebird 5 robot, then Firebird 5 tank is there, omnidirection robot that move in all the directions. Then we have insect that has some 6 or 8 legs. Okay. Then hexapod is there. It is just like look like it moves in all directions using the hexapod. And then also is where we are using a gripper here that will grip any object. So using Advanced Studio, we can program the robot. I'm going to show you this Atwell Studio here. So let me open this. Let it be open, and I will show you the environment where we can program our robot. It took some time to do that. Yes, Ruby.
Yes, sir.
Ruby,
Thank you
just
so much.
thank you very much. I think on the software will take some time, but okay. I think yeah,
Okay.
it's open. I just show them which software we are going to use. Okay.
Yes, sir. Thank you so much, sir, for the impactful presentation. And you have bounded us with your visionary thoughts and the practical explanation as well. And attendees, I'm sure you must have upgraded your skills by the inputs and learning shared by the expert of the day. So thank you so much, sir. And sir, in the meantime, we have with us our admission expert, Ms. Rachna Bajaj. So, ma'am, over to you for the admission part of the university.
Thank you so much, ma'am. It would be great if I could get the screen sharing rights.
Yes, ma'am.
Okay. So good evening, everyone. I hope you all are doing fine and safe at your home. So I'll be just quickly sharing that how you can get all the information related to admissions and the programs which are available at LPU. So what you have to do is just simply visit our website www.lpu.in, and on the top you will see an icon of admissions where we have segregated all the programs as per your qualification. It can be after 12th diploma programs, after 12th bachelor's program, after graduation programs, or after post-graduation PhD programs. So let's say if you are interested in any of the bachelor's program, just click on the after 12th programs, and all the programs or disciplines which are available after 12th will be available right in front of you on the screen. It can be related to engineering, management, CSE, commerce, etc. So let's say, I suppose we have students from engineering background. I'll click on engineering, and all the streams under engineering will be available. So I'll just simply go for electronics and communication engineering, for example, and all the specializations will be available right in front of you. So once you click on this program, you can see that the duration, which states that it is a 4 years program with total 8 semesters. Once you scroll down, you can see some of the industry immersions, the tie-ups we have for this program, the eligibility criteria, which clearly states that students should have minimum 60% in 12th with physics, maths, English as a compulsory subject. Apart from this, subject to qualifying LPU NEST or JEE main. So you should have like minimum 85 percentile in your JEE if you want to directly take admission in any of the engineering program. Once you scroll down, you can see some of the key highlights, the placements, the research work, the student achievements, the rankings of this particular program, and the curriculum for next 4 years as well. Further, once you scroll down, you can see the another important aspect, which is the fees and scholarship, the monetary aspect, I suppose. As you can see that the without scholarship fees for this program goes 1,20,000 per semester, but we have different categories on the basis of which you can avail scholarship as well. So let's say if you score between 85 to 90 percentile in JEE or 80 to 89.9 percentage in your 12th, you will directly fall in category 3, that is of 20% scholarship, and your fees will be reduced to 96,000 per semester. Let's say if you scored better, if you scored between 90 to 95 or 90 to 94.9 percentage in your 12th, you will fall in category 2, that is of 30% scholarship, and your fees will be reduced to 84,000 per semester. Last but not the least, if you score 95 percentile or above or 95 percentage or above in your 12th, you will directly fall in category 1, that is a 40% scholarship, and your fees will be reduced to 72,000 per semester. Let's say if you couldn't score well in any of these categories, you have LP NEST exam as well, because this test is not only for eligibility purposes, but it will also help you avail better scholarship. So this is the cutoff, the tentative cutoff, and the total number of marks for this test. And accordingly, you can fall in category 1, 2, 3 scholarship. Once you scroll down, you can see we have listed down some other important details, the highlights, other scholarships which are being offered under this program, and some important dates as well. And as you can see that the last date to take admission in this program is 30th September 2022. But students, I would like to tell you that the classes for this program have already commenced. So I would suggest you to proceed for your provisional admission, book your LP NEST exam parallelly, or apply, share the JEE result if you have already appeared for it. In case if you have any queries, feel free to get in touch with us. We have listed down our helpline numbers on the right side of the screen. We have a live video counseling icon. We have schedule a call icon. Our WhatsApp team is available for you. And down here, we have listed down our helpline number as well. So over to you, Dr. Ruby. I hope I have shared basic information which can be helpful for our students to apply for admissions at LPU. Thank you so much.